So in this video, we're going to talk through how to successfully work these four problems, which are all regarding heat and all use the equation Q equals mc delta T to solve. So if you have not done so already, I would encourage you to try and work these four problems on your own first using the material we've covered previously. Then come back and check your work and to see how you solve the problems to see if it matches what I'm going to talk about next. But without further ado, let's go ahead and address these problems. So for number one, I have given each problem a slide here. For number one, how many grams of water require that amount of heat to raise the temperature from 34 to 100 Celsius? And I give you the specific heat of water. So anytime I do a word problem, I like to write down the variables that I'm given, the actual number and unit. So I have done so right here. I have a Q of 2.20 times 10 to the fourth. I have my initial temperature, because that's the temperature I started with, of 34. Final is 100. I'm given my specific heat, which is the variable C in this equation. And I want to know how many grams of water. So in the equation, Q equals mc delta T, grams is a measure of mass. So I'm looking for mass. So here's the information that I'm given. I know that I'm going to be using Q equals mc delta T to solve for mass. But I see right now that equation is set up so that it's solved for Q. So I can solve this equation for mass by dividing both sides by C delta T. And doing that gives me this equation down here that's written more neatly because the C delta T, the C delta T cancels with the C delta T over here. So I have now been able to solve my heat equation for mass in a way that I can now plug in the variables that I am given. Before I start plugging in, though, I have to first calculate my change in temperature, which is always final minus initial. Doing that with 66.0 degrees Celsius. So using that delta T, along with the heat that I was given and the specific heat that I was given, I plug in my values appropriately. And I see a few things happen, which is good. I see my joule units cancel. I see my centigrade units cancel. I'm left with grams in the denominator of the denominator, which makes that be in the numerator. So I'm left with an answer in a unit that I would expect for mass. So that's one way you can check your work. Putting this into your calculator, 2.20 times 10 to the fourth, and then you divide by the product of these two numbers, should give you a final answer to three significant figures of 79.7 grams of water. So this is one type of problem that you could encounter using Q equals mc delta T, where you have to solve for mass. This problem is very similar to the problem that we did in the previous video, where we had to solve for specific heat. In this case, I'm given a mass, energy, and initial and final temperature. So I've written that all down here. I need to solve my heat equation for C. And so to do that, I'm going to divide both sides by m delta T. Doing that, my m delta T units cancel. So I am left with this equation that's written more neatly down here. I need to calculate my change in temperature before I put numbers into my solved equation by doing final minus initial. Then I can start substituting in values that I was given in the problem. My heat is 132.8 joules. My mass is 11.17. My change in temperature is 13.21. None of my units cancel. And that's good because specific heat's usually in joules per gram degree Celsius. So to 4 significant figures, should be 0.9000. In your calculator, it comes out as 0.8 with a whole bunch of 9s. I would probably accept that, but just to be consistent with sig figs, since I have 4 sig figs in my given information, my final answer should be 4 sig figs. So 0.9000. So let's go ahead and use the heat equation to solve for heat, actually. So this one's a little bit easier because the heat equation is set up. So we just need to solve for Q. We have a particular mass of water, 200 grams, heated from an initial temperature of 24 to a final temperature of 100. I want to know how much heat must be added. Heat is Q. Give you the specific heat of water. Once I find my delta T by doing final minus initial, I can go ahead and start substituting in values into my Q equals MC delta T equation. And I see that my gram units cancel, my Celsius units cancel. I'm left with joules, which is great. That's what I'm looking for. I'm looking for heat. Answer in joules. To 3 significant figures, the answer that you should get is 6.35 times 10 to the 4th. If you wanted to write it not in scientific notation, that would be fine as well. It would be 63500 with regards to sig figs. So I would say this is our 4th and final example for this video. If you can do a problem like number 4, you should have no trouble with the heat questions that are given on the quiz for this chapter, because to be successful in this question, you not only need to know the Q equals MC delta T equation that we've been using, but you need to also remember that delta T is equal to final minus initial, because in this problem, I give you heat, I give you mass, I give you an initial temperature, but I want to know what the final temperature is of this copper sample. And I, of course, give you the specific heat of copper. So looking at this problem, looking at least at Q equals MC delta T, there's no final temperature variable explicitly shown in that equation. But if I can solve for delta T, which I can because I have Q, M, and C, if I can solve for delta T, then I can take that and put it in this equation, add the initial temperature to both sides, and that will give me the final temperature. And so that's what we're going to do to solve this problem. We're going to first solve for delta T. So to do that, we take our Q equals MC delta T equation, divide both sides by M times C to get this equation down here. Plug in the values that we've been given, our Q, our mass, and our specific heat. When we do that, we see our cal units cancel, our gram units cancel, and we're left with degrees Celsius. So in your calculator, what you should get is this number here. And because I don't want to round just yet, I went ahead and I underlined the digits that are not significant, but I'm not going to round until the very end because I'm not done yet. What I have calculated is the change in temperature. What I need is the final temperature. And so I'm going to make use of delta T is equal to final minus initial. Solve that equation for final temperature by adding initial temperature to both sides, which I have done down here. Substituting in the values, my delta T and my initial temperature. And then rounding appropriately, I think what actually comes out is 57.6, but rounded would, or sorry, 57.6, but rounded would get rounded to the whole temperature, whole degree would give you an answer of 58 due to rounding rules for addition. So the final temperature for our sample is 58 degrees Celsius. We found that by first finding delta T from the Q equals MC delta T equation. Once we found that delta T value of 32.6086, we added the initial temperature of 25 to get our final temperature of 58 degrees Celsius. And that makes sense that our final temperature is going to be greater than our initial temperature because in the problem it said that heat energy is added. So that's one way you can kind of check your problem to make sure that it makes sense. So those are the 4 types of problems that you will see on the quiz and on the exam related to heat. As I said, if you can do one like number 4, you should be fine for the quiz. On the exam, there is another type of heat problem that makes use of Q equals MC delta T. It won't be on the quiz, but it'll be on the exam, and we will talk about that in the next video.